Let's do another example that involves the average cost. So if the total function is c of x, then the per unit average cost is given by the cost function divided by the number of units, x. So let's see an example of this. In this case, we have the total cost function is given by x squared divided by 9 plus 4x plus 100, and that is measured in dollars, where x represents the number of units produced. So the question is, how many units produced will result in a minimum average cost per unit? And after finding that, we need to also find the minimum average cost. Let's see how to do this. So let's start by finding the average cost function. So remember, if the cost function was given by this, then the average cost function that we're denoting as c with a bar x will be equal to the cost function divided by x. So in this case, this will be x squared over 9 plus 4x plus 100 divided by x. So simplifying things, we obtain that this is x over 9 plus 4 plus 100 divided by x. And now we need to find the minimum of this function. So first step always should be to find the critical values of this function. So to do so, we start by looking at the derivative, which will be equal to 1 over 9 minus 100 divided by x squared. And we want to find where this is equal to 0 or undefined. So notice that the derivative is undefined at x equals 0. On the other hand, this equation is equal to 0 when x squared is equal to 900, which is equivalent to say that x has to be equal to plus or minus 30. So the critical values are x equals negative 30, x equals 0, or x equals 30. So notice that x represents the number of units you need to sell. So x equals negative 30 makes no sense in this problem. The same happens with x equals 0. We're trying to see how many units we need to sell, and of course when we sell no units, we have no cost, and the average cost is in fact undefined. So the only one that is relevant to our problem is x equals 30. So now let's try to do some analysis that will tell us what is happening in this case. So the question now is the value of the function at 30 the absolute minimum? To check this, let's start with checking that we have at least a relative minimum at 30. To see this, we will use the second derivative test. So the second derivative of this function is 200 divided by x cubed. So this evaluated at 30, we can check that this is positive. So the value of the function is a relative minimum. We can check even more that if x is greater than 0, then the second derivative, it's positive. So the function is concave up when x is greater than 0. So this means that our function, when x is positive, looks something like this. And this one is the relative minimum that we found. So these two facts combined, that c has a relative minimum at x equals 30 and that the function is concave up, these two facts implies that this is the absolute value, the absolute minimum. So going back to our function, we get that the number of units we need to produce to get the minimum average cost per unit is 30, and the minimum average cost, C bar, of 30, it's equal to 10.66.